Hello everyone. So today we'll start with the polymers. So the word polymer can split into two parts, where poly refers to what? Many. Mer refers to unit. So what do you mean by that? There are many units joined together to form a polymer. A polymer can be compared with a pearl necklace, where pearl bead can be considered as a monomer and the entire pearl necklace can be considered as a polymer. So what is monomer? Monomer is a repeating unit which when repeated several times will end up with a polymer. And what do you mean by polymerization? It is a process of converting a monomer into a polymer. So now let us look on for the classification of polymers. So polymers has 4 different types of classification. So the first classification is based on the source. What do you mean by source? How it is available in nature. So based on source, we have 3 types of classification: natural polymer, semi-synthetic polymer, synthetic polymer. So the word itself is telling natural polymer, something which is available in nature, or to be more specific, the polymer which are obtained from plants and animals can be called as natural polymer. So what are the examples for natural polymers is starch, cellulose, protein, nucleic acid. I hope you remember starch, cellulose, protein, nucleic acids. They are all studied under another chapter called as biomolecules. So whereas another one example for natural polymer here is natural rubber. So let us move on to the next type, semi-synthetic polymer. So the word itself is telling semi, partially, synthetic, modified. So you're going to partially modify a natural polymer. Those polymers are called as semi-synthetic polymer. So the best example for semi-synthetic polymer are cellulose acetate, cellulose nitrate. So here you can see that cellulose is a natural polymer. We are modifying natural polymer, that is cellulose, by introducing acetate group and as well as nitrate group. Okay, so the another example for semi-synthetic polymer is vulcanized rubber. I hope you are seeing here natural rubber. Okay, so which is available in nature. If you modify certain properties, you will end up with an vulcanized rubber. So the third classification is synthetic polymer. So synthetic polymers are also called as man-made polymer or artificially synthesized polymer. Anything which is synthesized are called as synthetic polymer. So all the examples what we have to study in our syllabus, they are all example for synthetic polymer. To name a few, we have polythene, PVC, which is also called as polyvinyl chloride, nylon, Teflon, bakelite, etc. So let us move on to a next classification. So the next classification is based on structure. So here we have 3 types. First one is linear polymer, second one is branched polymer, and the third one is cross-linked polymer. So let us begin with linear polymer. So in case of linear polymer, if I take here, so here what happens is the monomers are joined together. So you have a very close packing of monomers to form a straight chain like structure. So you can see here that the monomers are very tightly packed. That means they have a very strong intermolecular force of attraction. So more the close packing, so you know that there will be a high density. Why? Because volume will be reduced here. So because of the lower volume, it will have a higher density. Not only higher density, it will have a high melting point, it will have a very high tensile strength. Then they are called as linear polymer. So the best example for linear polymer is high density polythene. Not only that, nylon, which is used as a fabric, which has a very high tensile strength, can be taken as an example for linear polymer. So the next is branched polymer. So here you should know the difference between branched polymer and as well as cross-linked polymer. So in case of branched polymer and cross-linked polymer, what is the differences? So in case of branched polymer, so here the monomers are joined together to form a straight chain. Along with the straight chain, it will be having a branches. So therefore it is called as branched polymer. Whereas in case of cross-linked polymer, what happens is, so here the two straight chain will be cross-linked with each other. Then it is called as cross-linked polymer. I'll repeat once again. So in case of branched polymer, the monomers are joined together to form a straight chain. It will have a branches also, but they are not connected with each other. Whereas in case of cross-linked polymer, so the straight chains are having a branches which are interconnected with each other. Then it is called as cross-linked polymer. So in case of branched polymer, as you all know that we have a branches, that is nothing but side chain. So because of that, you have a very low density, low melting point and low tensile strength, etc. Okay, so the best example is low density polythene, and another one is glycogen. So this glycogen you will study under biomolecules. Okay, so let us move on to a next classification, that is cross-linked polymer. So in case of cross-linked polymer, as I have said you, so the monomers will be having a cross-linked structures. So due to cross-linked structure, you will end up with an three-dimensional network-like structure. They will be very hard in nature, they will be highly rigid. The best example is bakelite. Not only bakelite, you can also take melamine formaldehyde resin as an example. Okay, so we'll move on to a next classification, which is based on intermolecular force of attractions, or to be more simple, we can also call as molecular forces. So based on molecular forces, we are classifying polymers into four categories. So the first one are called as elastomers, second one is fibers, third one is thermoplastic, and the fourth one is thermosetting plastic. So let us begin with elastomers. So here the word itself is telling elastomer, refer any polymer which has a elasticity as a property. They are called as elastomers. I hope you know that rubber is a best example for elastomers. So I hope you know that if I take a rubber band, if I stretch the rubber band, it will be stretched, and if I leave, it will come back to its original position. Why? What is happening there? So we know that in case of elastomers, they have a very weak intermolecular force of attraction, due to which you can stretch them. And why do they come back to a original position? Because they have a cross linking. So due to which they come back to our original position. So the best example is rubber. Okay, so the next one is fibers. What are fibers is, fibers are those polymers which are having very high intermolecular force of attraction. So what type of force of attraction they exist is, of course, they have a hydrogen bond, they have a dipole-dipole interaction. So all those are the strong intermolecular force of attractions which are existing in these polymers. And due to high intermolecular force of attraction, they have a very high tensile strength and they have a sharp melting point. So the best example is, you can take silk, nylon 66, nylon 6, any fabric can be taken as an example for fibers. Okay, so the next one is thermoplastic. What are thermoplastic is, so here the intermolecular force of attraction are existing between elastomers and as well as fibers. And another one special property of thermoplastic is, so it can be remolded many times, therefore it can be reused again and again. So the best example is polyvinyl chloride, polythene, etc. I hope you know that. The first classification is based on rubber, the second classification is speaking about the fiber, fabric, and the third and fourth one are speaking about the plastic. So thermoplastic, thermosetting plastic. So what do you mean by thermosetting plastic? So a thermosetting plastic is something which cannot be reused, again and again. Once if they form, they cannot be remolded again and again. Why? Because they are highly cross-linked structure. So the cross-linking cannot be disturbed. So therefore, they are the examples for the thermosetting plastic. The best example is bakelite. Okay, so this is regarding the third classification. Let us move on to a last classification, and which is based on mode of synthesis. Okay, so the last classification is based on mode of synthesis. So here, based on mode of synthesis, we have two types. One is called as addition polymerization and another one is condensation polymerization. Addition polymerization, I hope you know that you might have heard about addition reactions, which are highly characteristics of unsaturated systems or unsaturated substrates. The same concept is applied here. Addition polymerization can happen with those monomers which are having unsaturation. So here the unsaturated monomer keeps on adding without elimination of simple molecules like water, or it can be HCl, etc. So here water HCl can also be considered as a byproduct. So therefore I have written as repeated addition of the monomers without elimination of byproducts. So the best simplest example for addition polymerization is so polyethene, which is also called as polythene. So here the monomer is ethene. The word itself is telling here eth refers to 2 carbon, ene refers to double bond. So it is unsaturated alkene with 2 carbon, so it is called as ethene. So here you can see that the pi bond is involved in the polymerization reaction. So you can see here that there is a delocalization of a pi electron, or pi electrons are involved in the polymerization reaction, so that we will end up with a polymer called as polyethene. So here under addition polymerization, depending upon the type of monomer, we are further classifying them as homopolymerization and another one is copolymerization. So what do you mean by homopolymerization is, if I take a single monomer, I should take only one monomer and I have to do a repeated addition. But make a note, homopolymerization under addition polymerization, refer the monomer should be an unsaturated system. So therefore here we have taken a ethene which will undergo repeated addition where the pi bond will involve in the polymerization, that is delocalization, so that I'll end up with a polymer with a partial structure, and that is called as polyethene. Okay, so now what is copolymerization? So refer, I should take 2 monomers and both the monomers should be an unsaturated system and they should undergo repeated addition without elimination of simple molecule. So the best example for copolymerization is Buna N. So here Buna N, of course it is an rubber. So here Buna, we can split the Buna into two parts, Bu, where Bu stands for butadiene and capital N stands for acrylonitrile. So here butadiene, refer, it has 4 carbon atoms. Diene, refer, it is having 2 double bond. So the rest is you can fill with a valency. So here it is CH2, CH, again CH, here CH2. So this is called as butadiene. To be more specific, it is called as 1,3 butadiene. So this is one monomer, and the another one monomer is capital N. Capital N stands for acrylonitrile. So the structure of acrylonitrile is also very simple. If you know ethene, you just have to do a slight modification. What is that is, you have to remove one hydrogen and you have to introduce one cyanide group, where cyanide group is also called as nitrile. So therefore it is also called as acrylonitrile. So what will happen here? So it is very simple, as I have said you, the pi bonds are getting delocalized in addition polymerization. So this pi bond will shift here, and this pi bond will form a bond between this carbon atom and this carbon atom. So this pi bond will extend here. So you will end up with a partial structure like this: CH2 single bond, CH double bond, CH single bond, CH2 single bond, CH2 single bond, CH single bond with a cyanide group. And this itself is a partial structure or a repeating unit for a polymer called as Buna N. So I hope you have understood that in case of homopolymerization, I should take a single monomer. Single monomer repeated several times without elimination of simple molecules. If I end up with a polymer, then it is called as homopolymerization. Copolymerization, refer, I should take 2 different monomers and both the monomers should have an unsaturation and they get added up without elimination of simple molecules. Then it is called as copolymerization. Okay, so now let us move on to a next type that is called as condensation polymerization. So here, when does the condensation polymerization happen is, so here we have to take 2 monomers. And the condition is very important. What is that is, both the monomers should have a different functional group, so that when they are condensing, there will be an elimination of simple molecules like water or HCl or alcohol, etc. So here the best example is nylon 6,6. So we'll look on what are the monomers and how the condensation polymerization happens in next part. Okay, so this is all about the classification of polymers. Starter. Okay, so let us look on to the content which is covered for your NEET and JEE as additional information. So you should know about plasticizers. What do you mean by plasticizers is, so they are nothing but used for lowering the softening point. What do you mean by softening point is something like we can also call it as which reduces the melting point of a polymer. So it does not mean that a plasticizer can be used for converting thermosetting plastic into a thermoplastic. So this is not true. We cannot use plasticizers for converting thermosetting plastic into a thermoplastic. What are chemically plasticizers? They are high boiling esters or high boiling haloalkanes. Okay, so they have asked what are plasticizers. You should know that they are used for lowering the softening point or so-called melting point of a polymer. And you should also know that a plasticizer cannot be used for converting a thermosetting plastic into a thermoplastic. Okay, fine. So the next is regarding polymerization. So in our NCERT, I hope you know that we have a addition polymerization with a free radical mechanism. So let us understand addition polymerization, condensation polymerization, what are those? Okay, so here in case of addition polymerization, it is also called as chain growth polymerization. Why it is called as chain growth polymerization is because here you have a addition of monomers. I can call it as successive addition of monomers so that a chain keeps on growing. And the speciality of addition polymerization or chain growth polymerization is you will be having an reactive intermediates. So I hope you know that in your first year you have studied what are intermediates. We have three types of intermediates, that is free radicals, carbocations, carboanions. So here also we can expect addition polymerization with the free radicals as an intermediate, which you have studied in your second year polymers theory chapter with a free radical mechanism. And you can also expect addition polymerization with the formation of carbocation as an intermediate. And not only carbocation, you can also expect carboanions as also as an intermediates. So here, how to get a free radical? I hope you know that free radicals are obtained by homolytic cleavage. And here we have to add the free radical generators such as peroxides. So to name specifically, you can add benzoyl peroxide, tertiary butyl peroxide, etc. So if I want a cation to be generated, carbocation to be generated, I have to add an acid. So if I add an acid to a monomer, I can end up with a carbocation as an intermediate. In the same way, if I want a carboanion as an intermediate, we can add a base. Okay, so only so much you should know. So addition polymerization can happen with the three types of intermediates: free radicals, carbocation, carboanion. To have a free radical generation, we should add peroxides, which are called as radical initiators. To name specifically benzoyl peroxide or tertiary butyl peroxide. If I want a carbocation as an intermediate, I have to add acids. So the acids such as sulfuric acid or hydrofluoric acid. If I want a carboanion as an intermediate, I should add a base such as potassium amide, lithium amide, etc. Okay. So the next is condensation polymerization. Condensation polymerization is also called as step growth polymerization. So here you have to take a monomers which will get added up in a step wise so that you will end up with a dimer, trimer, tetramer, etc. So therefore it is also called as condensation or step growth polymerization. So now let us talk about coordination polymerization. So this topic I'll be covering again at the last, but here coordination polymerization are those polymerization reactions which are brought out by adding a solid catalyst. So to name the solid catalyst, it is called as Ziegler-Natta catalyst. So you are aware of Ziegler-Natta catalyst. What is it? It is a combination of titanium tetrachloride and triethyl aluminium. Okay, so we'll speak more about coordination polymerization at the last. Okay, so we'll continue further about the rubber. So I hope you know that rubber. So here natural rubber. So in case of natural rubber, the monomer present is isoprene. What is isoprene? It is nothing but 3-methyl 1,3 butadiene. Okay, so to be more specific, a natural rubber is an cis isomer. Okay, so it is a cis isomer of 2-methyl 1,3 butadiene, which is commonly called as isoprene. So you know that natural rubber is very soft in nature. It is very brittle in nature. So therefore, to improve the physical properties of a natural rubber, we carry out vulcanization. So what do you mean by vulcanization? It is a very simple process where you will take a natural rubber and you are going to heat along with the sulfur. The percent of sulfur, it depends upon the type of vulcanized rubber you should end up. For example, if I want a tire rubber, I should add only 5% of sulfur. If I want a battery case rubber, I should add around 30% of sulfur. And what will happen if I add a sulfur? So this sulfur will form a cross-linking to a natural rubber, so that the ended up rubber is called as vulcanized rubber, and that vulcanized rubber will be very hard in nature. Okay, so this is regarding natural rubber and how we are going to improve the properties of natural rubber to end up with a vulcanized rubber by a process called as vulcanization. So the next is, for your NEET and competitive exams, you should know about Gataparcha. This is very important question. So the difference between a natural rubber and a Gataparcha. So listen carefully. Gataparcha is also an natural rubber itself, but here it has a isoprene unit but with a trans form. So here isoprene with a cis form is called as natural rubber, whereas isoprene with a trans form is called as Gataparcha. Okay, so Gataparcha is a trans form, whereas natural rubber is a cis isomer. Got my point? So this is the difference between natural rubber and a Gataparcha. Let us move on for the rubber.